All right, let's start off with number 2 here. So for this one, we're going to solve the equation. I see that I have multiple powers, so I just want to get one side to 0 and factor. So I'm going to subtract 20k and add 5 over to this side. So I get 20k squared minus 20k plus 5 equals 0. And now I notice that all of these divide by 5, so I'm going to go ahead and divide them all by 5. So you have to divide that 0 by 5 as well. So it's going to be 4k squared minus 4k plus 1 equals 0. And now I'm going to try to factor it, thinking of two numbers that multiply to make 4 and add to make negative 4. And so that would be negative 2 and negative 2. Now I need to use my grouping here. So this just tells me how I split up my negative 4k in the middle. And I still need these guys out here. And so then I'll do my grouping here, and so put those together. The first group I can take out 2k, which leaves me with 2k minus 1. And the second group I can take out, I can't take out anything, so I want to take out either 1 or negative 1. In this case I'm going to take out negative 1, which will leave me with 2k minus 1 as well. And so I make one parentheses for these guys, combine them to make 2k. And then one parentheses for the stuff outside, which happens to be the same thing in this case. Now, since this is the same thing twice, I just need to set it equal to 0 once and solve. If I had two different things, I would do it twice, but in this case, I just do it once and I get k equals 1/2. All right, same idea here. I want to get one side to 0. I always like to move everything to the side that'll make my squared be positive, so I'm going to move everything over to this side. And we're going to subtract 4, okay? So then I get 2n squared plus 4n minus 2 equals 0. I do see that we can divide everything by 2, so I'm going to go ahead and do that just to make the numbers smaller. I'll get the same answer even if I don't do that, but just makes the numbers kind of easier to deal with. Next up, I'm going to think of two numbers that multiply to make negative 1 and add to make 2. I don't think this will work because if I do 1 and 1, that's not going to multiply to make a negative 1. And if I make one of these negative, it's not going to add to 2. So actually, these numbers don't work. And so sometimes this happens, so we switch to quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have my a here is 1, my b is 2, and my c is negative 1. So I go negative 2 plus or minus the square root of 2 squared is 4 minus 4 times a is 1, c is negative 1 all over 2 times 1. Just going to do some simplifying here. So I get negative 2 plus or minus the square root of 4, and then if I multiply these together I get negative 4 times negative 1, which is positive 4 all over 2. So I'm going to move up here, so I get x equals negative 2 plus or minus rad 8 over 2. And then I'm going to break this down since I don't really know the square root of 8, so that'll be got twin 2's right there, and I have a loner 2. So the twins will go outside, they'll kind of combine to make 1, and then the loner 2 will stay in the house. And then we'll just reduce it here with the heart. We're going to divide everything by 2. That's the biggest number they can all divide by. So negative 1 plus or minus radical 2. Technically all over 1, but I don't need that. All right, next up here, they want us to find the discriminant. So the discriminant is really the inside of the radical on quadratic formula. It's b squared minus 4ac. And if that's positive, then we have two real solutions. And if it's 0, we have one solution, one real solution. And if that's negative, we have no real solutions, or we have two imaginary solutions, because if it's imaginary, it's not real. So I'm just going to get my a, b, and c here. So I'm going to say negative 4 squared minus 4 times a times c. So that'll be 16 minus 16, so that's 0. So that's this one is one real solution. All right, next up, these ones we're going to solve by taking square roots. I'm going to isolate the squared first. I'm going to divide this by 49. Now 36 did not divide by 49, but I'm just going to leave it as a fraction, and then I'll square root both sides. Now since I created the square root, I need to put a plus or minus, and then the square root of 36 I know is 6, the square root of 49 is 7, so I can just write it as the fraction like that. All right, next up here, this one we want to use substitution. So since we have two equations, so I'm going to take this one and plug it right there. So I get x squared equals negative x squared minus 3x plus 2. So I need to get one side to 0. I like my squared to be positive, so I'm going to add everything over here. I'm going to add the 3x, and we're going to subtract the 2. So this will all cancel out, giving me 0. And then I put this one 2x squared first, and then 3x, and then minus 2. So now I'm going to factor, thinking of two numbers that multiply to make a times c, which is negative 4, and add to 3. So I get positive 4 and negative 1. We'll do that. So I do need to split this up since I have the 2x squared or some number in front of x squared. So this become plus 4x and then minus 1x minus 2. And now I'll group these together. So the first group I'm going to take out 2x, which leaves me with x plus 2. In the second group, it looks like I can't take out anything, so I'm going to take out a negative 1, which leaves me with x plus 2 as well. So now my two parentheses are going to be 2x minus 1 for the stuff outside, and then x plus 2 for the stuff inside. And that's all equal to 0. So now I'm going to split this up, set them equal to 0 individually, and solve. So this one would be x equals negative 2. And this one would be 2x equals 1, x equals 1/2. However, in this case, we need to find out what the y values are since we have the y values back here. So I'm going to plug them into the top equation just because it looks a little bit easier. So I need to plug them in separately. So this one first, we'll do y equals 1/2 squared. Now for 1/2 squared, we just square the top and square the bottom. So we should get 1 over 4. So my point there is 1/2 comma 1 over 4. And then for negative 2, I'm going to say y equals negative 2 squared. And so that's 4. And so this point would be negative 2 comma 4. All right, next up, we want to find the value of c that completes the square. So complete the square, we just have to remember, is b over 2 squared. So I just take my b value, divide it by 2, and then square it, and that comes out to 16. All right, next up, number 14, it says solve this one with a GCF. So I see that I have a k squared and a regular k, so that means I want to get everything on one side. So I'm going to add 32k over to this side because I want to get one side to 0 and factor. So I get 8k squared plus 32k equals 0. And then I see that both of these can divide by 8 and k, so I'm going to take that out front, and that leaves me with k plus 4. And now that I have this variable out front, I do need to set that equal to 0 and solve. And then obviously the parentheses here, like always, we set that equal to 0 and solve. So for this one, I'm going to subtract the 4, and x, or k, equals negative 4. And then on this one, I'm going to divide both sides by 8 to get rid of that multiplier. And so k equals 0, because 0 divided by anything is 0. All right, next up, number 16. So I need to find what type of function it represents. So I'm going to check and see what the pattern is. So I'll check it as addition. So it's plus 5 plus 10 plus 20, and then plus 40. So obviously that's not the same. So it's not linear. So next I'll check quadratic by doing that again. So that's 5, that's 10, and that's 20. So if that second difference was the same, this would be quadratic, but in this case it's different, so it's not quadratic. And so it must be exponential. And so exponential functions are always in the form of y equals a times b to the x. Now I know that a is always my y-intercept, so that's going to be 0, 5, or just 5. And then my b value I get by dividing any term divided by the term right in front of it. So I'm going to do the 10 divided by the 5, so that comes out to 2. So that is my b value. You can see that if I would have done b as 20 over 10, that would have also been 2. So I can really divide any two numbers that are in order. So then my final answer would be y equals 5 times 10 to the power of x. All right, next up here, we're going to do the same process, but I don't like how these are, some of them, fractions. So I'm going to go ahead and convert all of these to a common denominator. So I'm going to make This one 1 over 1, so I'm going to multiply that by 4. So it's going to be 0, comma, negative 4 over 4. And then this one is already a fraction. So I'm going to leave it like that. And then the last one here, I'm going to multiply this by 2. So it'll be 2, comma, negative 2 over 4. Okay, so now I'm going to check the pattern. So this one looks like it is actually a plus 1/4. Remember, a smaller negative is actually positive. Same thing here, and then same thing there as well. So that tells me, since these are all the same on that first go-around, is linear. And it also tells me what m is. The slope is 1/4. And then I already have my y-intercept right there. The y value in x is 0, so b equals -1. So I'll just write y equals 1/4 x minus 1.